Good afternoon, all students. My name is Sachin Kumar. I'm the lecturer of Polytechnic Mechanical Department and IIMT College of Polytechnic. Today, we'll discuss about the topic called the orthographic projections. Orthographic projection is a very important topic for engineering drawings and graphics. It is a very beneficial for the student of the diplomas, also in the BTech student. In case of orthographic projections, we have discussed in many content, many subtopics. First, we discuss about the orthographic projections, and after that, we discuss the first angle projection, and after this we discuss about the third angle projections, and after discuss we in the projection of point. In projection of point we have discussed about the first quadrant, second quadrant, third quadrant, and fourth quadrant, and how we can use in the first angle projection and third angle projection, and we don't we why we do not use in second angle and fourth angle projection. We will discuss in the next slide, and after that we will discuss about the projection of point. Because projection of point, we have different case lines perpendicular to HP, parallel to VP, parallel to HP, perpendicular to VP, and the lines are parallel to both the planes. After discussing the projection of point, we have discussed about the projection of the straight line in straight line, and after we discuss the projection of planes. So we start about the orthographic projection first. What is the orthographic projection of engineering drawing? Engine orthographic means ortho means angle is 90 degree, and graphics means the of design. Means orthographic projection is a method of the representing a three-dimensional object on a paper using several two dimensions view. If we draw the projection of 3D into the drawing sheet, how to draw? This method is used to drawing a 3D object in 2D sheet by two dimensions view. First, what is the orthographic projection? In next slide, orthographic projection is when the projectors are parallel to each other and also perpendicular to the plane of the projection is called the orthographic projection. What is the projector? We discuss in next slide what is the projectors, and the conditions of the orthographic projection is what is the conditions of the orthographic projections. So another method of drawing the projection is oblique projection and isometric projection and perspective projections. First, this is the simplest method for drawing any object is orthographic projections. So orthographic projections, we will discuss about the projectors. So that is the object, and this front view, top view, and side view. These lines are the projectors. We discussed in previous slide what is the projectors. These lines are the projectors. First condition of the orthographic projection is these lines are the parallel to each other, parallel to everyone. So these lines are the parallel to, and second condition of the orthographic projection, the plane of projection is perpendicular to the projectors. So in case of orthographic projections, two conditions satisfy. First, these projector lines are parallel to each other, and second condition is these projectors are perpendicular to the plane of projection. That is called the orthographic projection. In case of orthographic projection, in a 3D object is converted to 2D sheet, and in any view we can see front view and top view and side view, only two dimensions visible in a drawing sheet. So in case of what is the basic difference between the orthographic projection and isometric projection? In case of orthographic projection, the 3D object means convert only two dimensions can visible in any single view. But in case of isometric projection, we only in one view give the three dimensions in three dimensions, and also give the actual size of the object. So that is the orthographic projections. That front view, top view, side view, and we discuss this object in later. First, we are only define what is the projectors and plane of projections. So what is the projection? It is a technical drawing in which different view objects are projected on different reference plane, observing perpendicular to the respective reference planes. What is the planes? The different reference planes are, first is horizontal plane, and that HP denoted by the HP, that is vertical plane denoted by the VP, and side plane or profile plane, it is the VP. So three types plane used in case of the orthographic projection: horizontal plane, vertical plane, VP, and side plane. And side plane, yeah, or profile plane. And these planes are the perpendicular to the each other. After that, the different view are different view used in orthographic projection. First is front view, top view, and side view. What is the front view? Front view is the view projected on the vertical plane, and top view is projected in the horizontal plane, and side view is projected in the profile plane. Next, that is the fourth quadrant. In case of engineering drawing, that is the vertical plane. We discussed in previous slide. That is vertical plane, that is horizontal plane, and that is XY line. XY line is the intersection between the horizontal plane and vertical plane. It is the line between the intersection of the horizontal plane and vertical. This 3D diagram is how to draw in drawing sheet into the diagram. We will discuss in one by one. That is the first quadrant system, and there is a second quadrant, third quadrant, and fourth quadrant. In case of a first quadrant, the object is lies in the case of first quadrant, the means the object is lies above the HP and in front of VP. In case of second quadrant system, the object is lies above the HP, behind the VP, and in case of live, if any object lie in the third quadrant, the object is below the HP and behind the VP. If object is lies in the fourth quadrant, then object is lies below the HP and in front of VP. If we are drawing in engineering drawing in first quadrant and third quadrant, why we cannot drawing in the second angle projection and fourth angle projection? We will discuss in the next slide. That is front view. Always, if you any object in the front view go to the vertical plane, and top view go to the horizontal plane. So that is, if we 3D is converted in 2D, that point is the intersection of the horizontal plane and vertical plane. That point denoted by the XY line, and that is vertical plane in 2D sheet, and that is a horizontal plane in a 2D sheet. That is a observer, and this is first quadrant and second quadrant, third quadrant, and fourth quadrant. The any object is like any quadrant, we can define in this slide. If object lie in third quadrant, means object lies below the HP and behind the VP. So next slide we discuss about the methods of drawing orthographic projections. Means how to draw the orthographic projection, which method can use. We can use only two methods: first angle projection method and second and third angle projection method. And in previous slide we have discussed about four quadrant, but we can draw on the first angle projection method and the third angle projection method. First angle projection method is the object lies in the first quadrant, means object lies above the HP in front of VP. That is the first angle projection. If we draw the projection in first angle, means the projection is above the front view. Front view is above the XY line, and top view is given the below the XY line. In case of third angle projection, then object is lies below the HP and behind the VP. If we draw the projection of third angle projection, the front view is goes below the XY line, and top view is given the above the XY line. This is the basic difference between the first angle projection and third angle projection. In this slide, the representation of symbolic diagram, first angle projection is that is custom of cone, and third angle projection is that is the symbolic diagram of third angle projection. Only we have discussed about only first angle projection and third angle projection. Why we will discuss about the second angle projection and third angle projection, fourth angle projection? It is a very important question. In case of second angle projection and fourth angle projection, the front view and top view of any object above the above the XY line and below the XY line, the object front view and top view is overlapping, so that we cannot draw the in the projection in second angle projection and fourth angle projection, because overlapping of the front view and top view of the object. So we can use only first angle projection. Mostly India use is first angle projection, and other countries can use in third angle projections. So let us discuss about the one problem of first angle projection. So first angle projection means the object is lying first quadrant, means above the HP in front of VP. Let that we consider that is an object. So that is object for, if we see in the front view that is in top view and side view. Side view also is called so go to the profile plane. The front view, the projected in the vertical plane. If any object to we see in the front view, that is shape the rectangular shape in the vertical plane. Then top view goes to in the top view goes to the horizontal plane, and side view is go to the profile plane. Profile plane is that is the profile plane. So three different view is give the view in vertical plane, horizontal plane, and profile plane. That is the, in case of left hand side, you can discuss, we were at XY line. This object lies in the first quadrant, means the front views go to the above the XY line, we see in the right hand side and left hand side, and top views go to the below the XY line, and side view go to the above the XY line and right hand side of the front view. If we draw the any object in the first angle projection, then first angle projection, the front view always go to the above the XY line, and top views go to the below the XY line, and the side view is always in the right hand side of the front view. If any object lies in the first quadrant, if this question we can discuss in third angle projection, what you changes in the drawing we are discussing. Next slide means, if you draw this projection in third angle projection, then front view always go to the below the XY line, and top view below the above the XY line, and side views let we discuss in third angle. If this object is lies in third quadrant, means the object is lies below the XY line, below the HP and behind the VP. First representation of any object lies in third quadrant system means the object is lies below the horizontal plane and behind the vertical plane. Then another that is we can consider that is the object, and that is ground, vertical plane, horizontal plane. This is HP. This object lies horizontal plane and vertical plane. Front view goes to the vertical plane, and after that this is the profile plane. Profile side view go to the profile plane, and top view with the horizontal plane. There is a basic difference between the first angle projection and third angle projection. We see in the diagram in previous slide. The front view, in case of first angle projection, front view is always above the XY line. In case of third angle projection, the front view is in the below the XY line, and top. In case of first angle projection, top view is above the below the XY line. In case of third angle projection, the top view is always above the XY line, and side view also in case of third angle projection is below the XY line and right side of the front view. This is a simple drawing in case of first angle projection and third angle projection. In case of second angle, if you draw angle in the drawing in the second angle projection and fourth angle projection, then in case of second angle projection, the object, if you draw front view and top view, that is above the XY line, the front view and top view is overlapping. So we cannot drawing in the case of second angle projection and fourth angle projection. So next we discuss about that is side view. So that is a simple problem for the orthographic projection. First, if we draw the front view goes to the vertical plane. That is vertical plane. Then the vertical plane, front view. That is a, if we go top view goes the horizontal plane. A simple top view goes the horizontal plane. And there's a side view always goes the profile plane. These three planes, horizontal plane and vertical plane and profile plane, are the perpendicular to the each other. That is the orthographic projection. In case of orthographic projection, if we can see that we can first angle projection means front view goes to the above the XY line. We discussed in the previous slide, and top view always goes to the below the XY line. That is the top view is below to the XY line, and side view always below above the XY line and right hand side of the front view. This is another view how to draw side view. That is another method for drawing the side view. First we draw the front view, and then you draw the top view. And how to draw top view to side view? They make the angle of 45 degree in case of fourth quadrant, and the projection of top view is projected in the projection of top view projected in the 45 degree, and then extend to the first quadrant. Then we can draw first front view, top view, and side view. So simple, we can draw these angles. What is the next? We discuss about the quadrant and the planes. So we will discuss about the quadrant. We will discuss about the horizontal plane, vertical plane, right hand profile plane, and left hand profile plane. These are profile planes. Profile planes also is a side plane. So we are discuss about the first quadrant, second quadrant, third quadrant, fourth quadrant. First quadrant means above the HP in front of VP. In case of second quadrant, that is above the HP behind the VP. In case of third quadrant, below the HP and behind the VP. In case of fourth quadrant, below the HP in front of VP. If any object we are defined how this object lie in which quadrant. So first we define if any object lies in fourth quadrant, means this object is below the HP and in front of VP. If any object lies in second quadrant, means this object is above the HP and behind the VP. First, simply that is a simply diagram. That is vertical plane. That is a horizontal plane. That's the XY. XY is the intersection between horizontal plane and vertical plane. First quadrant, second quadrant, third quadrant, and fourth quadrant. So that is the front view. Front view always go to the vertical plane. We have discussed in class in next previous slide, and after that, the top view always goes to the horizontal plane, and that is the discussed in previous slide. This simply. So first we discuss about the projection of point. Projection point is a very initial topic for the engineering drawings, and first. If point lies A, then we can see the slide, point A above the HP in front of VP. What do you think about that? If a point A above lies in above the HP in front of it, means that is that point is lies in the first quadrant system. Means first quadrant is how to draw this projection of point in first quadrant system, that is HP and vertical plane. This is XY. If a point A lies in the above the HP and in front of VP. First we go to the front view go to the vertical plane, that is, and top view goes to the horizontal plane. A and denoted by the A dash. We are always remember, if we draw the front view, means we use we use the system, we use the dash denoted. If dash means we are drawing the front view. If we use any letter and always use the small letter. If you draw in top view, we don't use let dash. We don't use dash. We use without dash. So first, if you use front view, always use the dash. If you draw top view, we don't use dash. So for front view above the HP and below the VP. So that is point A, and the top view is goes to the horizontal plane. That is horizontal plane. That is the orthographic. We can in the blue we can say the orthographic view. How to convert these 3D dimensions into 2 dimensions? It is the rotational method used for the projection of point. The horizontal plane is rotated at 90 degree in clockwise direction. Then A dash A is a vertical line. So how to draw these lines? Always is that we are discussing previous. If then any object lies in the first quadrant, means the projection of this quadrant above the XY line, front views always go to the above the XY line, and top views always go to the below the XY line. So next is point A above the HP in the VP. Second is that is the point A, and that XY line. Point A above the HP and lies in vertical point line. First we draw the front view. Front view goes to vertical plane, that is A dash, and after that top view. Top view in this case go to the XY line on the XP plane and XY line, because the point A is lying the vertical plane. If we this point see in the top view, means that the projection of point A is on the XY line. So and after that we can use the rotational method, means horizontal plane is rotated 90 degree, and that 90 degree. So then HP and VP. So front view above the XY line and top view in the XY line. So we can discuss about the third point, point A in the HP and in front of VP. So how? That is point A in the HP horizontal plane, that point, and in front of VP. Also in first quadrant, from the top view, we can say that is the point A is horizontal plane, and front view go to the vertical plane. And that is simple A dash and A. Dash is used always in the front view, and without dash we can use in the top view. So that is XY line front view, because point A lies in the horizontal plane. If we see in front view, so the projection of point A is goes to the XY line. And in the previous case we have discussed, if the point A lies in the vertical plane and we see that point in top view, means this projection is go to the XY line. So this is a basic difference between the. So how to draw in a drawing sheet this object? Means how to 4 quadrant systems go to how to use draw in first quadrant, second quadrant, third quadrant, fourth quadrant, any point. So first we discuss point in a first quadrant. First quadrant means point above the HP in front of VP, and then HP plane is rotated 90 degree clockwise directions, and that is in case of first quadrant, the front view above the XY line and top view below, and top view go to the below the XY line. In case of a second quadrant system, means point above the HP and behind the VP, if we rotate the HP plane in 90 degree rotation, then we can see the front view and top views always above the XY line. In case of a third quadrant system, the point is lying below the HP and behind the VP, means we can rotate the HP plane 90 degree, then front view always goes to the below the XY line and top view goes to the above the XY line. In case of a point, if any point lies in the fourth quadrant system, means front view always goes to the vertical plane and top views goes to the horizontal plane. So means front view and top views below the XY line. So we can compare this 4 quadrant, how to front view and top view draw in the case of projection of point. So in case of projection of point, we can clearly see the first angle and third angle projection. The front view and top view is always above the either above the XY line or below the XY line. But in the case of second quadrant system and fourth quadrant system, the projection of point above either above XY line, above below the XY line. So in case of second angle projection, we discussed in previous slide. In case of second angle projection and fourth angle projection, the chances of overlapping is very high. So we cannot draw the angle drawing in second angle projection and fourth angle projection. So next slide, we will discuss how to these lines draw in sheet. So we have discussed in previous slide that point is in first quadrant, then front views go above the XY line and top views below the XY line. In case of second quadrant, the front view and top views go above the XY line. In case of third quadrant, point line in third quadrant system, then front views always above the below the xy line and top view above the xy line. In case of a fourth quadrant system, then front view and top view below the xy line. So that is simple case. So that is how to rotate that. We consider that slide, and the first quadrant is like first quadrant system. Point A, that observer, that is A dash, and top will go to the vertical plane. And that plane is rotated in 90-degree. That plane, if horizontal plane is rotated 90-degree, that point A, top view A in the horizontal plane, that horizontal plane rotated 90-degree clockwise direction, that will go to the vertical plane. So that is the projection of the in case of first quadrant system, that is A. And in another case, if project in case of if object lie in second quadrant system, then HP and VP observer, the point A in case of that is in second quadrant means above the HP and behind the VP. Then first A dash, front view go to the vertical plane and top view go to the horizontal plane. And then plane is rotated in 90-degree, means that then horizontal plane is rotated 90-degree, and A point go to the that horizontal point go to the vertical plane. So that is the case of if any point lies in the second quadrant system. So next we discuss about if any object or points lies in the third quadrant system, that is horizontal plane and vertical plane. And observer, the point lies in third quadrant system, that first goes the front view goes the vertical plane, that is A dash, and top view is the horizontal plane. After that, you use the rotational method, and the rotational method, that horizontal plane is rotated at 90-degree, and that A means A dash in vertical and straight line. Always remember, in case of a projection of point, we can rotate the horizontal plane for 90-degree and clockwise direction. All any quadrant system. Next, we discuss about the fourth quadrant. In case of fourth quadrant, means the point is lies below the HP and in front of VP. That means that point is lies below the HP and in front of VP. That front view goes to the vertical plane, and after that, that is denoted by the A dash, and top view is rotated in the horizontal plane, that is horizontal plane. After that, same process is followed. Horizontal plane is rotated at 90-degree in clockwise direction. That point is goes to the vertical plane. So that is the vertical plane, A dash. So we have discussed about the concept of the how to concept in a, we can learn in fourth quadrant if point lies first quadrant, second quadrant, third quadrant, and fourth quadrant by the rotation method. How to light front view and top view, or how can we can draw the angle of first angle projection and third angle projection drawing. So front view and top view of a point always lie in the same vertical plane. Yeah, if we can draw the front view with some important notes and points to come out for this discussion. That point we discuss about that. Front view and top view of a point always lie in the same vertical plane. All these cases we can see that is always front view and top view in the same vertical line. Second point, front view of a point P is represented by the P. It shows position of the point on the respect of the HP. Means if any point lies in the first quadrant, if any point lies above the HP, and we can use the front view always above the XY line. If any point lies in the horizontal plane, then P lies in the XY line. If any point lies below the XY, means any point lies below the HP, that lies, then projection of this point is lies above below the XD. And always we remember front view as denoted by the dotted A dash and B dash. Dash we can use in the case of a front view. So in case of a top view of a point P is represented by the P. It's the position of the point with respect to vertical plane. मतलब means vertical plane के respect में उस point की position क्या होगी. जैसे हमने previous में discuss किया था कि अगर कोई front view बना रहे हैं किसी point P के respect में, तो उस horizontal plane के respect में उसकी position क्या होगी. अगर point P XY point के मतलब अगर point P lies in above the HP, means that if you draw the projection, then the point P is lie above the XY. And then after that, if top view of a point P is represented, so it shows the position of the point with respect to the vertical plane. So if the point P lies in the front view of the VP, P lies below the XY line. If point P lies in the vertical plane, then lies on the XY line. If point P lies in the behind the VP, and then P lies below the XY. These are the conclusions we discussed in the previous slide. How to, if any point lies above the HP, and we can draw the front view to go the vertical plane above the XY line. If any point lies below the HP, we can draw the front view below the XY line. If any point lies in the horizontal plane, then we can discuss, then go to the xy line. This is the simplest point we have concluding in the previous slide, that is front view and top view. So that is the projection. A point a above HPN in front of VP, that is discussed. A point at the front view will always A dash, and top view go to the A dash. This is the pictorial representation. If any point B is lying horizontal plane and vertical plane, that point A lies in the vertical plane and horizontal plane. So front view always goes to the vertical plane and top view go to the horizontal plane, XY dash. So these terms we discussed in previous slides, and how to draw that point A dash and A dash. These three cases, the orthogonal representation in that. First is A dash, because point A in the first quadrant, the front view goes to the above the XY line, and top view go to the below the XY line. In case of the second case, because point A lies in the horizontal plane and point A lies in the vertical plane, so the top views always go to the XY line. In case of third quadrant, the point lies in the HP, means the front view always goes to the XY line, because if you see in the front view that A dash is in the XY line. So we have discussed in the projection of point. Projection of point means using four quadrant: first quadrant, second quadrant, third quadrant, and fourth quadrant. After we have discussed in projection of point, we have discussed about the projection of line. Projection of line is a very important topic for the engineering drawings, because point is the simplest. How to use draw the projection of line? First, we define the line, the condition of line. Line means line means this type of line, perpendicular to HP, parallel to position of line. First, you define position of line, means line is perpendicular to HP, parallel to VP, line parallel both the planes, line to inclined to HP, parallel to VP, and line parallel to HP and inclined to VP. Different cases we have discussed in the projection of line. First, in simplest case, a vertical line. Vertical line means the perpendicular to vertical plane and parallel to horizontal plane. If a horizontal line perpendicular to VP and parallel to HP, and line parallel to both the planes HP and VP, line inclined to HP and parallel to VP, and line inclined to VP and parallel to HP. And most important topic on this line inclined to both the HP and VP. So first we discuss in simple case. A line, first we discuss a line perpendicular to HP and parallel to VP, means it lines that is a vertical plane, and after that is a horizontal plane. We have discussed about that line. That line is perpendicular to HP and parallel to VP. So another we can see that is perpendicular to HP and parallel to VP. First, that is A and B. So first we draw. In case of projection of line, we always first consider which view gives the true length. If we see in front view and top view, if this AB line we see in the front view, is give the true length. A front view that gives true length in the vertical plane, A dash and B dash. So first always consider in case of line, which view is give the true length. So true length is given by the front view. So first draw the front view, that is A dash. But always remember, we can use the front view, so we always use dash. So A dash and B dash. We draw the vertical plane A dash and B dash. Front view A dash and B dash. In case of a top view, so top view we are seeing only point A, means A in the horizontal plane, A and B. So A and B. That is the simplest case of projection of line. That line is perpendicular to HP and parallel to VP. In case of, we can discuss another case, second case, a line to HP and VP. That is the interesting case. That is why? Because in the previous case we have discussed only front view gives the true length. Top view is not giving the true length, because top view gives the only point. In case of a second case, AB line is parallel both the planes. Means if you see in the horizontal plane, if we see the front view, it will be the true length. A dash and B dash, you can see true length. True length means actual length. We can see which view. If a line AB is 5 mm and the projection of the vertical plane is 5 mm, is the true shape we can measure in vertical plane. In case of a top view, if you can say top view, A dash B dash, means in this case, if you see in front view and top view, both the view is give the true length. So if we start in front view and top view, then no problem. But if any case, in any case of lines, we start first only if this view is give the true length. So that is front view and top view. That is the orthographic projections. We can say in the first problem, the line is perpendicular to horizontal plane, the perpendicular to HP and parallel to VP. So, and also if we do the front view is the perpendicular to XY line. So we can, in the right hand side in orthographic projections in engineering drawing, see XY line. Front views always goes above the XY line, A dash B dash, and perpendicular to the XY line. That is perpendicular to the XY line, and after that, that A and B. That front view is vertical lines, so it's true length. So top view is a point. In case of top view is point, we are simply, if we see in the top view, अगर हम top view से देख रहे हैं तो हमको सिर्फ point A दिखाई दे रहा है, B दिखाई नहीं दे रहा है, तो हम A को डैश से भी ब्रैकेट से डिनोट कर सकते हैं. इससे ये कंफर्म होता है कि आपका जो ब्रैकेट से मतलब होता है कि आपको सिर्फ यही पोर्शन आपको दिखाई दे रहा है, बी पोर्शन आपको दिखाई नहीं दे रहा है. So that is the orthographic pattern. So in case of second case, because both the view are given the true length, so A dash B dash and AB always the parallel to the XY line. So draw the projection of, and front view always above the XY line. In case of first angle projection, these drawings are we are drawing in the first angle projection. If these drawing are in the third angle projection, then the reverse and the front view always go to the below the XY line and top view goes above the XY line. So it's a, we can discuss in third case. This is a very interesting case. A line inclined to HP and parallel to VP. That is, this line is inclined to HP and parallel to VP. Because first in the projection of line, we have discussed which view is the true shape. Front view is given the true front view is the true length. So first we draw the front view, that is A dash and B dash. In this case, the top view is not given the true length because top view is given the shorter length. If AB length is 5 mm, we are, because it is making the angle of any angle for the horizontal plane. So top view is not given the true length, it is given the shorter length. So first we draw in the front view. So front view is A dash B dash in the vertical plane, that is A dash, and top view gives the shorter length in the horizontal plane. That is the orthographic projection in case of this case, we can first draw the front view. Because why you draw the front view? Because front view gives the true length, then A dash and B dash. After the front view, we can draw the top view in the horizontal plane. That is the orthographic projection of a line inclined to HP and parallel to VP. And another case we have discussed about top views parallel to XYs, parallel to XY lines. That is fourth, a line is inclined to VP and parallel to HP. That is, if any line is parallel to inclined, inclined to VP and parallel to HP. So first we have see which view is the true length. In this case, top view is given the true length. Top view is given the true length in the HP plane, and front view is given the shorter length. So first, which view you draw first? In case that is given the top views first. So in that orthographic projection, first we draw top view below the XY line, and after that we have draw the front view above the XY line. These two cases, a line inclined to HP and parallel to VP, a line inclined to VP and parallel to HP, means in these cases we can see if which view is given the true shape. So in case of third, front view give the true shape, means the front view draw first and then go to top view. In case of fourth case, the top views give the true length and top view draw first, and then after we draw in the front view. So always remember which view. In many cases, like line inclined both the plane, this is another important questions for the personal line. So first we use three methods for drawing a line inclined both the planes. So we will discuss in next lecture, but this is simplest case of a line inclined to HP and parallel to VP. Top view inclined to XV and front view parallel to the XY line. So first, in how did we are discussing projection of point and projection of line. In projection of lines, we can different line conditions. We can use a line perpendicular to VP and parallel to HP and parallel to HP perpendicular to VP, line inclined both the planes. First we have remember always to draw the drawing in drawing. So which view is given the true length in case front view goes to length, top view is given the true length, and side view also in many cases side view is given the true length in case of engineering drawing. So we have discussed projection of point. So little projection of line planes. We have discussed about the projection of plane. Plane, what is the plane? A plane is a two-dimensional object having length and width only. Its thickness is always negligible. Various shape of plane figure are considered such as a square, rectangular, circle, and hexagonal. in the different type of geometry of planes: square, rectangular, triangular, circle, trapezoidal, parallelogram, and pentagon and hexagon. And we have discussed only about the pentagons and hexagon. In the case of engineering drawing, regular pentagon. What do you mean by the regular pentagon? Regular pentagon means the all the sides of the pentagons are equal and the angles also equal. If the sides are not equal in case of a pentagon, that is irregular pentagon. In case of regular hexagons means the sides of the hexagons are equal, and also the angle of the internal angle and of the angle is same. In data is called regular pentagon. Maximum using regular pentagon and regular hexagon type of planes. In case of a projection of line, we are defined the line in different conditions. This type of line means perpendicular to a vertical line means a perpendicular to HP and parallel to VP. And in case of the horizontal line, perpendicular to VP and parallel to HP, this and line incline both the planes in same pattern and same way. Type of planes when used. What is the perpendicular plane? Plane which is perpendicular to the one principal plane of the projection and including and parallel to the both. An oblique plane means inclined to HP and inclined to other any reference plane, horizontal plane, vertical plane. So first we categorize the which type of plane used. That in that question is, if we take the simple questions. For in this question, plane PQRS is situated, means plane PQRS is a perpendicular to VP and parallel to HP. That plane is perpendicular to VP and parallel to HP. So which view is give the true shape? If we see in the top view, the top view is give the rectangular, is give the true shape PQRS. If we see in the front view gives the a straight line. So first we draw in all that we are drawing projection of point, projection of line, and projection of plane. So first we draw the projection which we give the true shape. So true shape given which view? Top view. So first we draw top view PQRS. We are drawing all the drawings in the first angle projection. We are discussing starting if we are drawing in third angle, the front view and top view position are interchanging. So all the drawings in lines and planes we are drawing in the first angle projection. So front views, we are saying front view PQ and QR. QR is not, we cannot see QR, only line PSR we are seeing in the front view. So line PR is, and that line is parallel to XY line, reference line. So first we draw the top view in PQRS, then we can draw the front view, and after that front view is always denoted by the dash. So we can use the P dash, Q dash, S dash, R dash, and after that a top view is given by the PQR, a rectangular shape below the XY line. If this drawing we are in the third angle projection, that's only interchanging the position of the front view and top view, and we can simply, this front view goes to the goes to the below the XY line, and top views goes to the above the XY line. So interchanging in case of first angle and third angle positions. So thank you very much for that. We are discuss about engineering drawings. First we discuss about the projections of we can use first angle projection, third angle projection, and after that we are discuss about the projection of point and projection of lines, and after that we are discuss about projection of planes in simple problems. We are discussing the simple problems. Projection of lines is a very important topic for the diploma student for first year, and also engineering student for first BTech student first year. So it is a basic knowledge of engineering drawings, and in the next lecture we have discussed about the different type of a projection of plane, projection of solid, and development and isometric projection. We are discussing the orthographic projection. We can see only one view, means only one view, front view and top view give the front view and top view give the only 2 dimensions. In case of isometric projection, one view gives the 3 dimensions, and front length, height, and width also. So thank you very much for the listening this lecture, and thank you, sir. Thank you very much.